So Yash, can you tell me the base address of Rcgc GPIO?
Wait a minute, sir.
Mm-hmm.
It will take me. Hold on. Yes, sir. आप किसका पूछ रहे हैं?
Rcgc GPIO,
Okay, sir.
the base address of that particular register.
RCGC register map.
You can keep your microphone muted. If you want to speak, then only you can unmute it. Okay. No
Yes.
issues. Let me see how you are going to approach to find the base address of Rcgc GPIO. Yes, did you got the value?
Sir, 400 E. Oh, wait a minute, sir. 400.
Note it somewhere along with you. Okay. Keep it noted on a sheet of paper.
Sir, 4000 F E 000.
Okay. So Mehul, any idea how to find the base address of Rcgc GPIO?
Yes. Just a minute.
By that time, Yash, can you tell me what is the utility of Rcgc GPIO? Array use paper pen. You cracked the JE using paper and pen. I don't know when you learnt everything to do in the computer itself. Hmm. So Yash,
Yes, sir.
can you tell me what is the utility of Rcgc GPIO? Why we have to know about this particular register?
I don't know, sir.
Don't know. Last lecture you were there, right?
No, I was
So
not there,
it
sir.
is 400FE608.
No, I asked the base address.
The
Base
base,
address of
the base address
RC.
is 400FE000 in hexadecimals.
So that's the base address. Okay.
Yes, sir.
Now you were talking about 400F E608. What is E608 there? Can you show the data sheet?
Yes,
What
sir,
is
this is
608? What is
so
the
608 is
purpose of?
offset for getting to
Hmm.
Rcgc GPIO
So where is the
from
base
base
address
address.
mentioned here? Where is the base address given here? Hmm. So do you understand why I'm doing this today?
Yes, sir.
Why?
test our understanding of the subject.
Because you never had any doubt, na? You guys never had any doubt. So now when when I asked the basic question, you are fumbling here and there and you are scrolling around the whole document, 1400 pages.
On page number 340, it was written. There is
So
more information of Rcgc
where are
GPIO.
you scrolling then?
Going to page number 340.
Can't you go directly to 347? So Yash, what is the utility of Rcgc GPIO? Hmm?
Sir, I was not present in the last class.
That cannot be the excuse, na?
So sorry, sir.
So if you are sleeping, does not mean Tuesday was not there, right? और जैसे बोलते हैं ना, तुम्हारे घर का मुर्गा बांग नहीं देगा तो सूरज नहीं उगेगा क्या? है? उगेगा ना?
So here it is written. The base address and the offset of Rcgc GPIO.
ओके. सो क्यों भाई यश, गलत बोला क्या कुछ? नहीं
नहीं
ना?
नहीं सर.
An excuse like this cannot be an excuse. For example, can you give such excuse when you are sitting in an interview?
No sir.
Or will you try to give such an excuse that I was not attending the class when this topic was taught to me? Or we were not having this kind of course, so I don't know about the C programming or any other programming. Will you? Why you will not give such answers at that time? I'm not, that means scolding you. I'm just asking to know why people have this kind of attitude towards regular classes. Because if either they should know everything, right? Or they should attend the classes.
No sir. I have
You are
missed only
paying a
the last class sir.
no,
I
no,
have
you
missed
are
only
paying a huge amount of fees. You guys are paying huge amount of fees. And this is the situation of some of the students who are regular, right? Hmm?
Yes
And
sir.
what about those who are not even attending?
Not aware of that.
I don't know. Maybe in future when they will try to get a job, they will get a job also in computer science, might be possible. And then you can ask them whether they are enjoying their job or not. Because in any domain, you cannot survive for long until unless you have the knowledge or you don't have the sincerity. You can crack JEE, but you cannot get very good marks in engineering. Even you can get good marks in engineering, but unfortunately you might not be knowing anything about the engineering. Or you might crack the campus interview also, but then down the line they will give you new tasks which is not there in your course or syllabus. Then how you will start searching for the answers? Hmm? I'm not saying that this course is just about electronics or hardware. Till now, this is only C, and we are just using the C programming to go to certain address. And if you were taught C in first year, then pointers, dereferencing these kind of topics, you must have been mastered in that topics. I don't know. Might be. You have mastered, but you don't want to tell me. Might be because you don't want to share the knowledge, right? भाई ये भी सीख गया तो. Anyway, so first we found out the base address.
Right sir.
And what is the utility of Rcgc GPIO? Can you read it out,
Yes
Mehul?
sir.
Hmm.
The Rcgc GPIO register provides software the capability to enable and disable GPIO modules in run mode. When
That's all.
enabled,
That's all. That's all. That's all. That's all. So what does that mean?
So
So
it
it
is
is
another
used to
purpose for
control
anti-aliasing
clock
type.
functions related to provide
GPIOs
clock to
to
uh,
GPIO pins. GPIO pins. What do you mean by GPIO pins?
general purpose input output pins
In general, what are
to
they?
to interface with external world to
So
device
all the
to
pins, yeah,
connect.
all the pins that you are going to use to connect to either a motor or an LED or any other device, or to read a sensor or any other type of functionality that you want to do. For that, you need to interface with the external world. You cannot keep on running the program within the microcontroller and expect everything to happen automatically. So you need to interface it. But here, before going to the GPIO, because ARM has introduced this particular concept, and why they have introduced. Can you tell me why they have introduced this particular concept? Any reason why they have introduced this topic? But because it is mentioned here itself, I am not getting anything from the uh, book or anywhere else. This is all provided in the data sheet. I'm just trying to teach you the importance of data sheet, reading the data sheet, going through the data sheet, and understanding how to write small programs. So, what is the why they are using RCGC this clock for ports?
For synchronization of data.
No, why don't you read it? When disabled,
When disabled, the clock is disabled to save power and access to module registers generate a bus fault. This
what does it
register
mean?
provide
Okay, okay, that's all. That's all. That's all. That one line is enough. Why they are using this particular clock?
so to save power.
To save power. Because why unnecessary you will keep the ports with high or low voltage? Keep it off until unless you require them to work. If they are not being utilized for any kind of external work or interfacing with external world, why you need to keep power giving power to that particular port? So you can save power, because microcontrollers or embedded systems usually work 24/7, and they are expected to work 365 days a week. Sorry, 365 days a year. So for that, if you calculate the power consumption, it will become a huge number. So now, so this is the importance. First, you have to provide the clock. So now the question is how to reach to that particular address, and which port we are going to work on. How to know that? Or you can go down a bit, go down a bit. Okay. Can you read the, okay, zoom in, and more. Okay. So what is the information provided below the register? Or what kind of information can you gather from this particular diagram and the statements below?
So there are different set of registers in it in different mode like read, write, read only.
Those are bits, not registers. Those are bits. What is the register here?
Rcgc GPIO.
RCGC GPIO. And how many bits are there in that register?
There are 608.
32, 32,
Arey,
Uh,
read the number 0 to 31.
32.
No, don't scroll it
just
up and down.
0 to
Keep
31.
it stable. Keep it stable. Don't have to scroll it up and down to search everything. So 31 to 0. How
Yes,
many
sir.
bits are there?
32.
Why 32?
So this is one bit, so it makes 32.
What? Okay, clear. You can say, I'm not scolding you, just asking you. Why 32 bit in this register? Any reason for that?
Because there might be different I
Okay,
mean
yes.
operations.
Yes, can you tell me why this is 32-bit register? Don't scroll it up and down. Keep it stable. Don't worry.
Because each
Keep it
register
stable.
in the microprocessor it takes 32 bits.
Because the microcontroller is a 32-bit microcontroller. So all the data and all the registers are 32-bit registers.
It's
And now, out of 32 bits in the Rcgc GPIO, how many bits are useful and how many are not useful?
The 6 bits
six
are
are useful.
useful,
6 bits are useful, and rest of them are
reserved
Read only.
reserved. Why they are reserved?
for future products and
See here, to provide compatibility with future products.
yes,
If the company is going to upgrade something or introduce more ports or something like that, in that case, they still have these reserved bits which can be used. Okay, so which port are we interested?
we are interested from bit number 5 to bit number 0 here.
But read that bit 5 is for
The GPIO port F run
okay,
mode clock
okay,
gating
that's all.
control.
Okay, okay. Yeah, pin bit number 4.
GPIO port E run mode clock gating control.
Rest of the thing is common. Run mode clock gating control is common. Come down.
Yes, sir. GPIO port D, C,
Hmm.
B, and A for till.
Same, right?
Yes,
So if you want to work with port A, you will use bit number 0. If you want to work with port F, you will use bit number 5. Clear?
yes, sir.
And what is there inside that bit? What can we do with those bit? Go to or go up. What can we do with this bit?
We
This bit
can
can be 0 or 1. Okay.
Enable clock.
Yeah. You can enable that particular port or you can disable that particular port. Clear?
yes, sir.
But assume now a second question. If you have not enabled the clock of any particular port, and still if you try to access it or you try to work with it, what will happen?
So there is some default.
You know, you have read it before, just few minutes ago you have read that particular statement. If suppose you try to
It's in
access
power
any,
saving mode.
yeah,
So
that's done, but apart from that, that is done. Go up, second feature, you read that same line, when disabled.
when disabled, the clock is disabled to save power and access
And
to module registers generator bus default.
what does that mean? If it is disabled and if you try to access it, what will happen?
The clock is disabled.
No, you are reading the line and still you are not able to decode. One part says the clock is disabled to save power, and second part,
Access. Just a minute.
battery is running low. Ah, yes. Can you
Access
tell
to
me what
fault.
will happen?
Bus fault.
Bus
Bus
fault.
fault.
Bus fault means where it falls. This particular term, fault.
Bus fault. That we are that it's not enabled and that we are approaching that.
No, no. In which family this kind of signals are falling, or in which family these signals basically fall? Interrupts, exceptions.
Yes,
Because
sir.
when
Interrupt.
you try to access something which is not allowed, then it will generate exception. So that is one exception here, which is bus fault. So if you have not initialized the clock and if you try to access it, it will throw an error. Okay, so that's why we need to first provide the clock to a port to work with it. But now the question is which port we are actually interested. Suppose we are trying to make a program to blink an LED and we don't want to use any external LED, then in that case, which port should I use? How can I know that?
We don't need to access the external LEDs.
No, we don't want to connect any external LEDs. We want to use the LED within the board. I have specifically talked about the
Peripheral.
board and their components within the board. So suppose if you want to glow the LED which is there in the on the board itself. For example, in Arduino also the LED was connected to pin number 13. So where should I search to find the where the LED is?
This register map, maybe
No,
we can get the port address of LEDs and we can.
no. This will provide you the just detail of that particular register. Where is it going to provide you the information? Suppose some company might connect an LED on some other pin number. Is it necessary that all the companies will follow the same TIVA C?
So
There are
peripherals.
STM, Samsung is there. There is Apple. So how you will know? Hmm.
So peripherals, mein?
No, I provided you four documents.
Right, sir.
Check which are the four documents.
Yes, sir.
These are the problem because okay. Now which document might provide you the details of the LED and connections and all?
Reference.
Reference manual is for which component? It is for the microcontroller. No, don't open it. Come back. You're talking about the microcontroller. It is going to provide you all the details of the microcontroller. LED is connected externally by some other company, or some company might use some other pin and some other company might use some other pin. So where I should go and check?
So then instruction set.
No, come on. Again, instruction set how it will tell you where the LED is. It is about the microcontroller. It is not about the
TIVA C.
board.
Now only one of it is left. So it must
Of
provide.
course, simply. So this is the alternative answer that you can generate. Yes, click on that.
We have that
So this
evaluation tool.
shows, this shows, since the very beginning I am talking about, go through the data sheet, try to learn these things. Please read this data sheet, try to understand them. I'm not saying go through all the lines. Okay, come down where you can get the detail.
Page 4, sir.
Page
Page
number
number
9.
4. Okay,
Page 4.
click on that. This is what?
So
This is
this
the
is TIVA C series launchpad component location.
component location. Might be okay. Go up again. This is not where you can directly find the LED's detail. Go up. Go. Come down. Okay.
So there's a board overview on page 4.
Yeah. Go to that.
Oh, page.
But here again, it is not telling you where in which port the LED is connected. Right? Is it providing that detail? It is telling you that there is an LED, but is it providing the detail where is the LED on which pin number?
R5. No. D1.
D1. Zoom it. Why are you scrolling in such a small font? Zoom it. Zoom it in. Zoom. Zoom in. Zoom in. Or zoom. Okay. Go to
Gpio.
schematic. Go to schematic. Can you see any line which talks about schematic?
Schematic.
Schematic means the circuit diagram. Schematics. Yeah. Go up. Go up. Go a bit up. You are very guys.
Schematics.
That's the thing. Go to 19. Page number 19. Okay.
Schematic.
Come down.
Okay, sir.
Come down. So where is the LED connected? So this shows. You know what this shows actually, that this kind of engineers we are producing just by mugging up some numbers and some equations or some details. You will not be able to produce any result in the real world. Just check how much time you are taking to go to this particular page. or to go to this particular data sheet. Otherwise, if I would have not provided you all the four data sheets, I don't know how you will go and gather all the informations. And since the very first year, we are talking about schematics, the PCB diagram, and all those stuffs, even the design lab also. Anyway, zoom in.
So it is
So
connected here in port F LEDs.
okay, note
R
these numbers. Note these numbers. PF0 is connected to.
PF0 is connected to user switch to.
Note it somewhere on a page, preferably, so that you can practice writing also. Okay, it is not that good engineers don't use pages; they use more pages. Anyway, PF1 to LED red, PF2 to LED blue, PF3 to LED green, and PF4 to user switch 1. Make a note of this 4 or 5 components. And now, can you tell me which port we should activate, or which port's clock we should activate? Is it that difficult now? Which port's clock we have to activate now? Hmm?
The fifth
No, sir.
Hmm?
So
Which
one,
port?
one, two, and three.
Which
R1, R2.
port? I'm saying which port, not the pin number. I'm saying which port you have to activate, because Rcgc GPIO is going to activate a port, the whole port. Which port are you going to use then?
this bit number 5.
Bit number 5 you have to enable, because you want to use the switches and LEDs which are by default connected to this particular pin. Done. Make note of that also, that you have to activate or make bit number 5 of RCGC GPIO 1. Bit number 5 should be 1, so that the clock will start. Done. First thing. Clear?
Yes.
So first the clock is activated. Now we need to go to the GPIO's base address, because this was about the clock. But which GPIO we are interested? So for that we have to go to the GPIO register bank. Where is that? Perfect. Go to register map. Yeah, perfect. Come down. Okay, which port are you interested now?
Port F.
Port F. What is the base address of port F? Wait.
4002 500.
And yeah, so that is APB. What does that mean, APB?
So this one was high performance bus and this one was
Peripheral bus, legacy
peripheral
bus.
bus.
Okay, so first we will work with the legacy bus. So note the base address. Okay, so what is the base address?
4002 5000.
Okay, done. Next, we need to figure out three things, because now we know that how to activate the clock. Second, we know the base address of GPIO port F. In the GPIO port F, we are now interested in some of the pins, like the direction. Direction means whether that pin is going to work as an input or an output. How can I find that detail? How to find whether that particular port or pin, now we have to focus about the pin also. So
So it was
that pin has to be input or output. So how to find that?
read write pin.
Go down, go down, go down. So each port has got these registers mapped to each port. So now, first I told you we have to specify what? The
Base address.
Base address we got.
Yes, sir.
Now we need to know,
Offset.
no. We need to know which register will provide us the direction. That means whether to use it as an input pin or an output pin. Which pin, which register will provide you that detail here?
A GPIO data. Maybe read write.
Come on, it is. I am telling you direction, and you still cannot identify the second register. Eh? I'm telling you again and again. It
Oh,
is
yes, sir.
direction register, and still you are getting confused. So what is the offset for GPIO DAR?
Uh, 400.
So what is the complete address of GPIO DIR?
40025400.
Okay, make note of that offset number and note this particular register DIR. Go to that register, page number 663. Scroll down. Go to 663. Just beside the contents, there is a page number. You just enter that number and that's all. Yeah. Here, what it says. Okay. Go up. Don't scroll too down. Okay. What is this register going to do?
The GPIO DIR register is the data direction register.
Hmm.
Setting a bit in the GPIO DIR register configures
Hmm.
the corresponding pin to be an output, while clearing a bit configures the corresponding pin to be an input.
Okay.
So when we provide 1 to it, it acts as an output, while if we
0, it will become input.
input,
So switch is an input or output? Switch is an input device or output device?
it's an input device.
LEDs?
Output.
Okay. So now we know that offset is 400. Base address we know 4000 to 5000 because we are using APB. Okay. Now, how to use this register? Now you can close your screen and let Yash continue. If you need, you can speak in between, no issues. If you have
Yes.
any doubt, you can ask. Okay. Now, Yash, can you share your screen?
Yes, sir.
Okay. Okay. So, is it visible to Mehul?
Yes,
Mehul,
sir.
is it visible? Okay. So, can you tell me what are the or what are the bits available and how to use them in this particular DIR? That's all. No. You are at the right data sheet.
Yes, sir.
Okay. Now,
So 0 to
yeah,
7.
0 to 7. Okay. What are the 0 to 7 going to do?
0 means input and 1
Hmm.
means output.
Okay.
One,
So, can you tell me which pins are LED and which pins are switches and what should we do with them?
which pins are LED?
Yeah, you might have noted it.
Which pins are?
Because now what you have done, you have reached to the base address of port F. Then from there you reach to the direction register, and now you have to specify these bits will be used as an input or output.
Yes,
So
sir.
which pins will be input and which pins will be output? If you have noted on the paper, then it will not be that difficult.
The input for output will be the LED pins, no?
Yeah, LED is output.
So 5. Uh,
Okay.
yes, sir.
Now tell me the list, complete list. That
I
this
thought,
bit will be input, this will be output, and so on.
so I have noted only for LED, sir.
Come on, there are two
R5.
switches. Two switches also.
Yes,
Okay,
sir. Which is,
two switches
Port
were there.
number F0 and port number
Yeah.
F4 are switches.
So how
F0.
you are going to enter that number? Either you can directly enter that number into this particular register, DIR register, or you can use another technique which we will disclose later. Okay, this is about direction to define whether the pin is going to work as an input or an output. Clear?
Yes, sir.
Why it is necessary? Because of course any pin should be declared as an input or output. Otherwise it is not going to work according to our wish.
Yes, sir.
For example, if tomorrow you are going to use a transmitter, then this pin or any other pin you have to specify this pin is going to work as a transmitter. If you are going to make it a receiver, you will have to specify that this is going to be receiver, so input. Anyway, now this is about dir register. Now we have to tell this particular microcontroller that we are going to use this pin, okay, the led pin, for digital read and digital write. Why? Because like I told you before, one pin can work in different modes. It can be analog, it can be timer, it can be UART pin, it can be SSI, and so on. So whether you are going to use it for ADC, DSC, or some other purposes, you have to specify it. Okay. So now here we have to specify that this pin will be digital pin. Which pin? The LED pins.
LED pins.
So assume you are going to blink an LED, a red LED. Okay. So what is the address for red LED?
FPF.
FPF
So PF 1.
PF1. Where is that address in DIR? In DIR, you will have to make that particular bit 1, the bit number 1. Okay. Now, to enable digital enable, you have to find the next register, digital enable. Go up in the register bank.
Register bank.
Yeah, the of the GPIO,
Okay.
register map of the GPIO. Okay, can you find which pin can configure our pin as a digital pin out of these registers?
Digital enable
Yeah. So what is the address?
is 51C of
51C. So what is the final address of this register?
4002 E51C.
Right. Note that thing also and go down to that page and read what it can do for you.
Page number. Page number 652.
Hmm. What it can do for you?
It's a digital enable register. By default, all GPIO signals except those listed below are configured out of reset to be undriven. Their
Hmm.
digital function is disabled. They
Hmm.
do not drive a logic value on the pin, and they do not allow the pin voltage into the GPIO receiver. To use
So
the pin
this
as
is
a
how the engineer, yeah, this is how the engineer goes through each particular register bit, what to say, to write a driver file. Okay, come down to the directly to that register here. So it talks about the base address and the offset, and you can easily decode the address of GPIO DEN, right, to enable the digital. So since you are going to use LED, red LED, you have to enable that this LED is going to work as a digital LED. So which bit you have to make it 1?
digital. So we can which we have to make once one.
Yeah,
We have
the
to
LED 1. LED red is at pin number 1. Port F pin number 1 is a red LED.
yes sir.
So all these registers are doing, or they are helping you to go to that particular pin only.
Yes sir. So wait a minute.
Mhm. Okay. So Mehul, you can continue.
Yes, sir.
Yes sir.
Okay. Okay, leave it. So now, till now, what we have done, we have enabled the clock, so the port is active. We have identified the direction, whether the LED is input or output. Then we have told the system that it is going to be a digital output. Okay, that is clear now. Third is to write some data on that, whether you make it 0 or 1 at the end to make that particular pin on or off. Okay, depending on that. So go up and check
So GPIO data.
how to, yeah, GPIO data pin. So what is the base address and what is the offset address? Go up. Yeah. So base
Zero.
address is GPIO data. Base address is,
सब बेस एड्रेस भूल गया बिल्कुल.
go up.
400 to 5000.
402500.
Yeah, because that's the port F
बेस एड्रेस. Yes.
and it does not need any offset. So that is the basic base address of GPIO data. Okay, go to that pin if you that register and read what can it do for you.
Data register in software control mode, values written in the GPIO data register are transferred into the GPIO port pins if the respective pin have been configured as outputs to the GPIO direction.
Clear? So that means now we can enter some data into that. Okay, and rest this 9 to 2 and all these things I will tell you later. Now, first thing,
Yes.
now we have listed all the base addresses and we have listed all the the offsets also.
Yes.
Okay, so and now we have to enter some data into those particular registers. Okay, so till this part it is okay. So now we have some clue about what we are doing and why we are doing, why we are going to that registers and how to enter data into those registers. Now stop sharing your screen, I will share my screen.
Okay.
Okay, is it visible now?
Yes, sir.
Yes, sir.
So in the last class we were discussing about that. Wait a second. Okay, so can you tell me why we are going to this address 400F E608? What is this address?
So it's the address of RCGPIO.
You can check if you have noted down these addresses. It
Yes,
won't
sir.
be that difficult to cross check. Okay, I can make it bold if you need or caps on. So FE 608. Okay. Hmm.
This is for Rcgc GPI.
So and why we are entering 20 into that? 20 means this 20. How can you write it in hexadecimal? 2.
001000.
Okay, this is a 32-bit register. Clear?
Yes, sir.
And we have discussed why it is 32-bit. Now we are entering 20. What does that mean? Because to enter a 32-bit value, you should enter something like this: 000. So 48. Well, right? This we should have, or we should enter this value, whereas we are entering 20. What does that specify here? So all the zeros which are okay preceding or presiding this 20 are ignored, so it does not matter. So at the end you are going to enter 20. So what is 20? 20 is, if you break it down, 00000000 and so on, and here 00000000 and 20010, right? And then now you understand why we are entering 1 here.
Yes, sir.
R5,
Why?
sir. R5.
Bit number 5. So D0, 1, 2, 3, 4, 5. Now does it make any sense why we are making pin number 5 1?
Yes, sir.
You have to enable port 5.
Port
Port
I
5.
mean
F.
port F.
Port F. Why port F? Because all the LEDs and switches are on that port that we decoded from the data sheet of the microcontroller board. Similarly, if tomorrow you are going to work with any another microcontroller board, you will have to take the data sheet of that microcontroller Of course, this same TM4C123GH6PM will be used in so many different microcontroller boards, but each company may use different ports to connect with the LEDs or switches. So in that case, you must know where the LEDs and switches are. Now, every time to write this whole stuff, okay, and last class I told you this is nothing but this part is used for this particular address. Okay, in this address you are using type casting, so that by any means we don't want to enter a signed value in this particular address, because we want every number to be unsigned. So that's why, for a safety purpose. Now second, here there is a star in front of any variable or any address. If you put a star, what does that mean? It is pointer to that address, and we are going to dereference the register with the data. So dereferencing means entering the value into that pointer or that address. So to enter value into this address, there can be many methods, but this is the safest approach which C provides, so that you can use pointers, typecasting, and then the data. So now this data will be entered into this register, and what will happen then? It will enable the clock of port F. Okay, then what you are doing, rather writing all the time, writing the same stuff again and again for different registers or different addresses, it will be a very cumbersome job. What you can do, what you are doing here, define, and you are using a name, better name for it. And what is this particular thing doing here? It is called pre-processing. And sorry, okay, preprocessors or pre-processing. Okay, so now what will happen? Instead of writing this whole stuff again and again, I can simply use this common name, which is more feasible to read, more easy to read, and more easy to work with. Clear? So now instead of using this whole stuff again and again, I will be using this particular name. Okay, and instead of writing this whole line, what I can do, I can use this particular word and enter the data. Why? See here, from Rcgc space, okay, there is a space here, and then you are, whatever you specify here will be represented by this particular word or the preprocessor or a macro, and that's all. Now instead of writing this whole stuff, you can simply write Rcgc Gpio 20. Simple. So you activated that particular port. But of course, for one time you will have to write this thing, and then second time you never need to write this again and again, because you can use a simplified version of the register, which is defined by you itself. Okay, so let us go through the code, and let me check if you can understand what we are doing and why we are doing. And one more important concept has to be cleared, because whatever I have taught you in the C programming, we are going to now use almost all of them together to make programs. Okay, so I hope you have the IAR opened, and I am going to show you this particular lines. So it is clear now why we are using this particular complex name, define, Rcgc, Gpio, this. Clear?
Yes, sir.
Yes, sir.
And then what we are doing, because look here, the base is always common, port F base is always common, right? So what you are doing, you are using GPIO base, or you can give it a better name, GPIO port F base, right? If you want, you can rename it GPIO port F base or GPIO F base. Simple, sober name. And then what we are doing here, GPIO base plus offset. It makes the same sense. What is the offset? 400. 400 is dir. Clear? So everything is now, I believe it is getting clear why we are doing all this. So we know the base address, we are going to call it by this name, and everywhere we want to go for an offset, we will take the base address and add the offset address, and we will reach that particular port. If you need, if you want more clarification, you can put GPIOF base, GPIOF dir, GPIOF den, GPIOF data. That will be a better name. Of course it will be a better name. Okay, now coming down to the main function. In the main function, we can write some data into the address by using dereferencing technique. This is the dereferencing technique. You can use the pointer, go to that address and enter the value. This is called dereferencing. But again, like I said, if you keep on writing this stuff, okay, it will take too much time. So what we are going to do, we are going to use these macros to simplify our life, and we will use this particular line, Rcgc GPIO 20. 20U means it is unsigned number. 20U. So that means we are going to enable the fifth bit. Okay, it should not be register. Fifth bit, because it is not fifth register. Okay, it is the fifth bit of GPIO. I can make it more clear. GPIO port F, clock getting register. So we have activated the clock by making the fifth bit of GPIO port RCGPIO registers. Fifth bit we made 1. Done. Clear? Okay, done. Similarly, now we can specify, either we can use this technique, which is again a very cumbersome job. Otherwise, we can use this technique. Now, can you tell me why we are using 0E here? 0E. DIR 0E.
Because hexadecimals, I mean, there cannot be
What
a
is what is
E
the value
at
of
the first.
0E? What is the value of 0E? 0 0 0 0. Then 1 1 1 0. Right? E is 1 1 1 0. Right? Or wrong?
Yes, sir.
So
Yes, sir.
D, okay, so D0 is 0. What does that mean? It means it is an,
Enable.
no, the direction register will tell you about input or output. Right? So input or output. So 0 will make it what?
Input
0 will
and
make it
one.
input. Cross check, cross check, cross check, cross check. DIR. DIR register. If you can check DIR register,
Zero
let
is
me know.
input. Zero is
Hmm?
input and one is output.
One is
Output.
output. Okay. So don't predict anything. Okay. Always believe on the data sheet. Some companies even change that part also. Okay. So anyway, so you have decoded that part. So why we are making these three one? D1, D2,
uh,
D3, 1.
to enable RGB LEDs, RBG,
So yeah, we
so
are
to make
enabling
them
or not
output.
enabling. We are just telling that this should be, these three pins will act as an output. That's all. And what are connected to these three pins? The LEDs. We are just informing that these three pins will be output pins.
Output.
Right now we have only informed about this part. If you don't want to work with green or yellow, you can just make it 0 0 again. Clear? Now, since we are just telling the system, we are going to use the 3 LED as an, not the 3 LED, we can precisely say these 3 pins of port F will work as an output down, and then GPIO digital enable. What is the utility of this particular register? To specify whether these 3 pins will act as a digital input output or analog input output or any other purpose. So basically, it is just digital input output. So therefore we are entering 0x again. Okay, 0 0 0 0. 1110. Now does it make sense that we are making all three pins digital pins? Done.
Yes.
Now I believe you know this particular line, while one. Why we use this particular function, while one? This particular function. What is the use of this particular function, while one? Anyone? Okay, come on. You have studied
Infinite loop.
C programming.
Infinite loop.
Yeah, this is infinite loop. Repeat it continuously.
Yes, sir.
And this was what I was talking about. Arduino. Okay, let me just open any of this. Okay, so infinite loop. So let us check from which end to which end we have the infinite loop. So we have infinite loop starting from here up to here. Okay, up just before the return zero. What are there inside the infinite loop? First, what we are doing, we are initiating a variable integer name counter. It is very clear, right? Now this one, why we are using GPIO data? What is the utility of GPIO data?
To specify LED.
No, to make that pin 1 or 0,
Yes.
the data that we want to enter into that. Till now, all these three registers, what they were doing, providing the clock. So I don't know what is the data on the pin. Second, the direction. Okay, but what is the data on that pin? We don't know. DEN, digital enable. But what is the data on that pin? I don't know. So if I modify some data, or if I want to change the data on that pin, I will need GPIO data. Please read it again if you have not understood this particular register's behavior or the utility. Now we are entering 0, 2 here. Again, why? 0, 0, 0, 0, 0, 0, 1, 0. Why we are entering this particular value? So this is D1, right?
R1.
D1, R1. What is that pin? Or what is connected to that pin?
So red LED.
Red LED. So what we are doing here, 0, 2, that means making 1. So what it will happen? What will happen on that particular bit? It will become
So
high.
output.
It will become high. Output you have defined here, yeah, direction. Direction tells whether it is input or output. Sorry, this one, direction register. Direction tells it is input or output. Digital enable tells whether the pin will be analog read, analog write, digital read or digital write, whatever, digital function or analog function. Data changes the value of that pin or allows you to change the value of that pin. Clear? So if
Yes,
you
sir.
are making 2, then that means D1 is making high. That means the LED will glow. Okay, LED will be on. Let us come down here. Now this particular function, it is not related to embedded at all. What is this function doing here?
It's a delay.
Yeah, it is a delay. So you are checking while counter is less than 10 to the power 6. Okay, it's less than 10 to the power 6. Keep on incrementing the counter. And once it tries to get beyond 10 to the power 6, it will come to this line. What is this line doing again? This line,
Turn, turning off. Blink.
turning off. And what we are doing here,
Initialize counter 0. To an,
0.
again.
Why? Because when you have reached to 10, 10, what is 1 million, okay, then after, of course, if you start from this particular loop, it will not going to work for you. So you have to reinitialize it. And then what you are doing, again reinitialized and waited. And then after that, from here, because this loop If you check here, I told you this while loop is infinite loop, okay, and it will go back to this particular value, int counter equal to 0, and then the whole stuff keep on repeating itself. If you don't use this while function, okay, if suppose you don't use this function, okay, and this function, then what will happen?
We can't see the change, the blink.
Because the microcontroller is working at 16 megahertz, and if you try to make the LED on or off at that particular speed, the LED is not going to work. The diodes do not work at that high speed. It is very difficult to see whether the LED is getting on or off. Even beyond 200 or 5, even beyond 200, if you try to check, you will not be able to find any switching. So this is why we are making these two loops. Again, it is your choice whether you use or you whether you want to use while loop or for loop. You can of course do the for loop also here, right? For that you can use for bracket counter, right, uh, is equal to 0 colon counter less than 1 million, okay, then okay, 3, okay, okay, and then it is your choice. So beyond this is not embedded C. You will make it curly braces, and here you can just come, okay, you can make this particular line commented. Done. So it is your programming skill. It is none, it is, it does not have anything to do with the embedded now. Okay, so in this way we can continue with different programs, and we can make the LEDs
नहीं sir,
one or
वो
the,
pencil pen color
no,
चलेगा.
what happened? Wait a second, wait a second, let me just comment this part also. What happened? For counter equal to 0, counter less than equal to this, or less than, okay, this counter plus plus, what will happen? I'm making
ये
it 0.
GPIO pen करना.
Yeah, again I will make, look, GPIO is off now. For making it on again, I have to write that part.
So we have
Yeah,
to
this
take this
part.
out of the loop.
Yeah, no, but in the while loop will be there. It
Uh-huh.
will be all in the while loop. For example, let me show you. Control C. No, I will not use programmers. Notepad. Notepad plus plus. Just take an example. Oh, leave it. Okay. See. So this part is clear. We are using while function. In that function, we are going to remove this part. Clear, right? Or if you
Right.
want, we can just keep this data here. Control X, and rest we can delete here from here. Okay, and we can use this data inside. So while this is infinite loop, okay, inside that infinite loop, with what we can do, initialize the counter. So int counter equal to 0 by default, and then we can make for loop for, wait a second, for control J, no, no, it is not filling, auto filling, okay, control J, no, no, okay, for this counter is equal to 0 semicolon counter less than, okay, any number, then semicolon counter plus plus, okay, and then I will use the curly braces. Yeah, enter, curly braces closes. Then I will bring this particular, sorry, I'll bring this here. Is it clear now? First we are making it off, okay, for this particular time period. Then after that, control C, this I'll make it 0 2. But before that, I will have to make the counter reinitialize. Yeah, it is reinitialized again, so nothing to worry about it. So I can declare it outside also while loop, right? So once it is initialized, then the whole for loop will manage the things. Is it clear or not, or is there any error in this part?
Yes, sir. It's clear.
Hmm?
Clear, sir.
So it is your choice, okay. And remember, this still is a local variable. If you take this out, control X, if you make it here, here it will be a global variable, and we can check global and local variables in IAR also. So there are so many things that you can explore in IAR, but you have to be you have to program. Programmers cannot learn just by watching the videos. You have to work, you have to modify the things, keep on changing the things anyway. So this is how the program is working here. Control Z, okay. Okay, so here we are clear that what is happening in the program. And so if suppose you don't have the board, assume if you don't have the board, and here we have not specified anything about the board. What we are doing here, go to project, options, general options. We have specified the microcontroller only, because it is about the microcontroller, it is not about TIVA C or something. Okay, come down, and once you go to the simulator, okay, because you are using a simulator, okay. And if you try to run this program, what will happen? So I will just first rebuild the program and check if there is any error. Okay, one line is unreachable. Okay, one line is unreachable. Why it is unreachable? Because this is outside the infinite while loop, right? So it will never, the program will never reach to this particular line, because every time the program will return from here back to here. Clear? That's not an issue here. So unreachable is not a big issue here. Okay, now, but when you run this program, okay, or try to debug this program, and suppose you keep on clicking, so right now you cannot see any effect on this particular devices. So you will not see what is happening here. There is no clock is working, and there is nothing changing in these things. Okay, for example, if you want to go to GPIO port A, and you can see there are so many data already present in GPIO port A. And if you want to go to the RCGC GPIO, so these are clocks. Okay, so system control pins. So RC, रुको देखते हैं, let me say RCGC. Okay, in that there are so many things to explore now. But even in that case, right now you cannot see anything changing here. Okay, that effect you cannot see here until unless you connect the board, because when you connect the board, okay, things will change. But still, let us go through this particular uh, details, and let us check whether these registers are changing or not. So by default, these are the registers content, okay. And RCGC, we can keep an eye, whichever register changes it will become red. So right now the pointer is waiting here. Go to the next line. Okay, so RCGC GPIO, we have entered 20, but here we cannot see any effect on RCGC GPIO. Or I can just type here RCGC GPIO. Okay, see here 20 has been entered. So this register is taking that data. Okay, we have entered 20. Okay, so that means the port F is getting the clock now. Cool. But in that case, if I go to the port F, which is GPIO port F, so GPIO A, B, C, D, come down. GPIO port F is here. No, but here, right now, let us check what is changing. So GPIO DIR is here. So right now there is a vague or garbage value. Next, you see it is 0E. So direction register got the value. DEN. Okay, DEN is somewhere here. Okay, next. So DEN got GPIO port F, DEN got 0E. But why not DEN is getting 0E here? What happened? GPIO port F, DEN is not getting the clock. Not getting the value here. So something is wrong. Is the address correct? Base address check. Check 551, right? What is the address of the offset? GPIO port DEN. Let me go to the data sheet.
So 51C. 51C.
51C. That's the issue here. Okay, so let me go to GPIO. DEN 51C. So I have to go to that particular register. So it should be 551 instead of 51C. Okay, let me just stop the debugging and make it compile it again. Done. And let us check all the things how they are working. Done. So we have to wait here. Let's go down. Okay, so DEN is here. Go down. Now you see DN also got the value 0E. Perfect. Now int counter equal to 0. So this is a variable. So for that, which window I have to check, or which window shall I open to check the variables? Anyone? Which window shall I open? Go to debug, go to view, and go to watch window. The watch window, I will keep it here. In the watch window, I can enter the variable name counter. Right now it is unavailable because it has not been initialized yet. Okay, so counter got 0 value, and the location of the counter is R1. Where is R1? It is on the CPU registers. So R1 is here. Right now it is 0. Okay, then GPIO data we are entering some value. Again, if you want, go to port F, GPIO F, and data register. Here is the data register. Okay, let me go down, and you can see 02 has been entered. We are assuming that LED is on here. Now keep on go quick. Now here the problem is, now you cannot keep on clicking this, right, for 1 million times. So what is the solution in that case? How can I know my program is working fine or not? Because now it will take a generation to complete this clock by clicking on and off and on and off. One solution is, when you're simulating, take a very small value just for namesake, and later you can take an appropriate value. Okay, for that let us take 3. Okay, because it will take only 3 or 4 clicks to finish this loop, because we are not in the debugging session, so it is not going to affect us. We are not looking at a very precise timing, where we are checking only whether the program is running smoothly or not. So we have checked all this part. So counter is 1. You can check here the watch window, counter 2 and counter 3. It came out of the loop, and then it is going to make the data 0. So 0 again. Done. You came back. So 0, then 2. So in this way, the program is running smoothly. I can stop it, and once I'm satisfied, I can change the value to any appropriate value which I like. Okay, we will come to those numbers also, how to get perfect number to make the LED on and off at a particular time. Precisely, suppose you want to make the LED on at 1 second, 2 microsecond, okay, and you want to make it off for a period of 2 seconds, 5 microsecond, you can precisely make it on or off using these particular approaches. So this is how you can make the program. And let me just show you what is the difference between using the board and using the the simulator. Okay, so what I'm going to do is right click options, and I'm going to TI Stellaris, okay, which is the debugger for this board. Okay, done. Now let me just rebuild all. Now I am going to work on the board directly, and I'm going to see the effect on the board. Okay, so how can you know whether the board is connected or not? For that, what I can do is I can go to the program, and now you see what has changed here. Can you tell me what has changed here? For example, GPIO F. Before we were looking at GPIO F. Where is that? This one. Okay. So let me go to this DRA reset. Okay. And now, so right now, okay, this has been executed. So you might have checked what are the things that have changed. GPIO A or GPIO B. So GPIO F is getting some data. GPIO A, what is the difference between GPIO A and GPIO F now? Can you figure it out? GPIO F is having some data, whereas GPIO A or any other GPIO for namesake, okay, GPIO E assume, okay, which is close to GPIO F. So here GPIO E, you see what is the difference here? They are containing some dashed lines. Why they are dash or blank? It is signifying here? Why the GPIO port E registers of GPIO port E are with this blank dash lines? So what is the
Resolve,
significance?
resolve,
What happened?
no, no, resolve नहीं पता.
No, tell what happened. What is this particular lines signifying? Whereas it is not there in GPIO port F. Okay, why? Can you correlate something? Here there is no clock provided, so they are all disabled. Now, if suppose if I try without activating the clock, what will happen? I will stop the debugging. So let us check what will happen. I'm just commenting this particular clock. So I'm not providing the clock to port, but even without providing the clock, if I try to access the registers of that particular port, what will happen? What will happen? We have discussed it. What will happen if I try to execute this line?
So interrupts, bus fault.
Bus fault will happen. Let's check. So right now we cannot see any bus fault. Let's check here, down. So no bus fault. Why? Let me just stop it. Go to TI Stellaris and reset the board. Okay, I have rebuilt all. I have not enabled the clock. Okay, done. Let's check. Okay, at the same time I will use the disassembly window also. So go to this view And of course we can keep an eye on disassembly window also, this one. Okay, here, where the program is actually going with respect to every instruction. So right now we are here. Let's check. No, it is not throwing any error. I think it has. Now you can see my system is hang. Understood. And if I pause the program, keep an eye, okay? If I pause the program, because right now we are trying to debug, pause it. You can see where the program is right now halting. See here,
हाँ
where is
बस
the
फॉल्ट
program?
लिखा था.
See here. So this is how whatever we study, we can correlate the things. It is not just, I'm not teaching this course just okay, for namesake. You can just learn the things and all. And fault exception window has also generated, and here also you can see call stack exception frame error. So from all our different sides we are getting errors. Why? Now you can understand, because we tried to access the registers of a particular port without providing the clock to it, without activating that particular port. So that means the bus means the lines which are taking the data to and from the microcontroller to the GPIO port will generate error. And this is what bus fault error. How can you check that? Okay, in future, suppose you are writing a program and suddenly your microcontroller or your program halts, then of course you should pause it and see where your program is actually residing. And then after that the program will not work. Whatever you do, it will not work. It will keep on that particular error. Otherwise we can of course write some programs which in C we call it, what kind of programs we write to handle the errors like this: exception handle programmings, where if a particular kind of error is generated, we can generate a particular message without stopping the program. Or before getting into that error and stopping the program, we can generate a message, throw out a message that this particular error has taken place. Okay, one more important feature. You might have heard about volatile in C. Have you heard of volatile? Word volatile, keyword volatile. We have 2 minutes and we can just finish this topic. Have you heard or not?
No sir.
No. Okay, volatile is a very important keyword. Okay, which actually tells the compiler that the specified variable may change its value even when the program is not deliberating the same. What does that mean? It means in front of any variable, if you put the keyword volatile, then we are telling the compiler that don't take or don't throw errors when this particular variable's data change without even program's deliberation. It is generally used when we are using switches and all, because in that case the switch input is not changing due to the program. It is changing due to the external interference, or sometimes even interrupts may change some data. So in such case, to keep it safe, we have to use volatile. Second thing, sometimes the compiler, these compilers which are generating programs or which are compiling your program to assembly language and from there to machine language, they use different optimization levels. Optimization means make the program as short as possible. Throw or you don't use all such variables which are meaningless, don't make any sense in the program. Okay, just don't use such variables. So in that case, the optimizer will try to neglect all such variables which don't make any big sense in the program. So it is optimizing. It will shorten the program or it will make the program faster, but it may actually sometimes make or generate wrong results. For example, uh, we were using counter, right? And the counter is not a very important variable in the program. and the compiler knows that this is a simple variable which is keep on increasing. So it will, like I will show you now. So it will just neglect that variable if you if you put the project options. Okay, go to uh, options. Let me check. Optimization level, library 2, I believe. No, no, Mr. C. No. Okay, let me check where I can check the optimization level, because I can, yeah, here. From here I can go to this part. Wait a second. Optimizations. So C++ compiler and then optimization. Here there are four options. No optimization level, low optimization, medium optimization, high optimization. So if I make it high optimized, highly optimized, so these options will be automatically enabled and we can disable them also. But suppose it is highly optimized, and we are telling the compiler to generate a very highly optimized code. Okay, and assume we are not going to use the keyword volatile. Okay, we are not going to use this particular keyword. Okay, so what will happen if I don't use that particular keyword volatile? I will just delete this part. Okay, let us check what will happen. Before it was generating the code for counter and all. I will just rebuild the program, and now it is rebuilding the program on maximum optimization level, and I am not using the board. Okay, so you can use even the simulator to check the working. So simulator, okay, done. Okay, because the same program will be transferred to your microcontroller board also. So now here let us check. So here main GPIO counter, let's go down. Okay, and you see what happened. You see, did you notice what happened here in this case when we are using high optimization? The program actually neglected this whole part of the program, which it felt that it is not necessary. So therefore, to avoid such conditions, we should always prefer to use volatile keyword in front of the variables. Otherwise, during optimization level, the program may neglect such variables, or otherwise make the optimization none or low. In that case, of course, it will keep the counter variable with it. Okay, but don't go to check that particular detail, rather use volatile keyword. So this was about the volatile keyword. Okay, and this will end the lecture here. We'll meet in the next class. Thank you.